Welcome to our workshop. We are Neurolabs, and our workshop is on democratizing computer vision. That sounds fancy, but that's a nice way of saying we want computer vision accessible to developers. How do we plan to do that? With a low-code platform. You'll have to see it. Okay, so we will be showing you the software design challenges that go into getting computer vision into deployment. So we'll go through the software engineering challenge, a bit on the ML, and put a lot of focus on the web platform. We'll be doing a live demo on that. So if you have your laptops, get those ready. And yeah, we'll first go a bit into some technical details though. Okay, so a bit about us. We are an 18-people startup. We are working in computer vision. I've been with Neurolabs for 3 years, and my colleague Mathias has been with Neurolabs for 1.5 years. I'm working in the computer vision team. This bright fella is the whole engineering team, and we've done, I think, some amazing stuff. So, to give you a quick briefer on how a computer vision pipeline looks like. First step is collecting real data. These are the images you need to train your models. You get some annotations on those, and then you start training your models. Once you train your models, you check the performance on data you haven't trained with on, and you get to deploy them so people can actually use them. In object detection, we've split here the two tasks. We call one localizer and one classifier. The localizer is identifying that there is an object in an image, and the classifier says which object that is. Yep. Okay. What makes us different? We try to do it with synthetic data. So computer vision models are notoriously data hungry. You need thousands of images for good models. We're talking in the millions on unsupervised learned algorithms, and that's not scalable to some point unless you're Google or Facebook. So what we want to do is synthetic data. That means data that we can vary anything on, think about the number of objects, the lighting, what objects we include in scenes, and what we want to do with that is to have millions of available instances at a fraction of the cost. So no annotations involved. Sorry. But synthetic data is super cool, and you can see it there. Okay, yeah, next one. And I'll pass it on to Mathias to talk a bit about how this computer vision pipeline comes together with the synthetic data in a way that people can actually use it.
Thank you. So there's a general approach. We're going to guide you through the things with the platform live. Hopefully everything works as expected. And then you guys can all try it out on yourself. This is the sneak peek of how how the software currently looks like. Just a brief overview on how everything comes together. I think most of you are developers, so you might be interested in the technologies we chose so far. So we use a Postgres database, a relational database, because all data is kind of relational. Maybe the MongoDB guy would have a different opinion in that. And we use regular SQL. We have a Python backend written in Fast API. Makes it quite easy because the ML guys are using Python as well, so we can exchange people a little bit and have a nice, I don't know, a good flow with the same programming language. And last but not least, there's a front end. It's currently written in React TypeScript, and it's, I don't know, React. And it's supposed to be cool. And we do have a production and staging environment, but I guess that's like just a replica for us to test out. The bigger thing, you can read it in the back, I guess, but like the upper part is the stuff that I just told you. Then we have a lower part, a small, tiny piece of software that we call Yoshimitsu. And that one is responsible to make all the ML magic work with all the different platforms or things we have. Maybe it's the thing off, I don't know. So with the different ML stuff that we have, and this one is interacting with the different things we have, Velohigh, MLOps platform, Docker, whatever.
Okay. Oh, okay. So going back to the ML components, we're going to talk a bit about the elephant in the room, where the ML magic happens. Like most of the research in computer vision is usually directed in these steps: training better models and finding ways to evaluate on a benchmark data set. And I would call that the model-centric approach to computer vision. So just a brief reminder on how convolutional neural networks work. You get an image as an input. You do a lot of linear mathematical applications, operations, and you obtain a set of what we would call features that represent what you have in the image, be it shape, color, and combinations of them. CNNs are what's usually used in production nowadays in computer vision applications, but transformers are definitely making a run for their money. But there are limitations to the object detection way of training computer vision models. So in the classical approach, what you would go for is have an input, an image for which you have a label. You train a convolutional network. You train a fully connected layer, which would output a class for your image. And this task, this is similar to asking the question, is this a dog? Now, once you've trained this, these layers can only represent the classes you had at train time. And that's a big limitation. So what we want to go for is a different approach on which we don't construct a model that can say, is this a dog? We have a model that can say, are these two instances in the same category? And what we use for that is something we call embeddings. So after your convolutional networks, you get a one-dimensional vector that contains all the features I talked about before, so like shape, color, whatever else. And you can have a representative for this image. Now, what that does is allow you to get a representative for each image and dynamically add images to your pool. So you essentially get unlimited classes, but there's a few drawbacks to that. Okay, so here's a representation of how your space would look like. These are 512 dimensional vectors, which we have reduced to just 2 dimensions for visualization. If that doesn't make sense, it's just a math nerdy way to say these points represent images, and each color represents a class. So instead of having a convolutional layer that says dog, not dog, you have here, let's say, the representation of all your images that are a dog. And all of these other clusters of points would be different representations of different classes. So your problem now becomes, which of these is the closest to my new image, and assign the class based on that. Yeah. So that's the ML of it. And we thought we had everything we needed to just go into production, and that should be easy. But it's not as easy as it sounds. So the steps that usually end making or breaking an AI project don't happen in the ML magic. They happen in the collect real data, annotate, and deployment steps. So you can see these very high failure rates on projects. And yeah, no, it's okay, it's okay. And yeah, can you go back? Yeah, and what these steps need, what these steps can do is allow you to get the billions of images we talked about before as a requirement for computer vision models, and a way to serve them to people. So in your collect real data and annotate QC steps, our solution is synthetic data. But in our deployment step, we need to look at something else. And we're going to look at something called MLOps. What is MLOps? It's a set of practices that aim to deploy and maintain ML models in production. Think of this as your DevOps meets data engineering meets AI discipline. And what you need to do here is to make sure your models have a way to reach prototypization to production. And yeah, and this is and this can sorry about that. The heat is killing me a bit. This is not a new domain or an easy domain. This is something we're learning as we go. The ML community does not have a lot of research on it. So if you have any expertise on this or want to learn more about it, hit us up, definitely. Okay, and now we go to the demo.
I'll try to guide you through the different workflows we have currently implemented in the software. If you want to dive right in, I'm going to hand out some credentials for our platform. You can just pass it along. It should work. We'll see. And I'll come back to this slide, I guess, later. It's called app.neurolabs.ai. And you should log in with your credentials and tell us if it doesn't work, then you get a new pair of credentials. It's going to be quite interesting with the microphone in one hand, to be honest, but let's see if I can make that work. All right, so that's the platform. And in the future, we will have many more products. We don't know where those products will actually come from. Maybe from the manufacturers. Maybe we're going to build them ourselves. Currently, we build them ourselves. And, well, you can onboard a new product quite easily. Let's call that an apple that we want to create, just to confuse you all. And then you have like different categories that you can choose, for example, fruits, and it's also a grocery. And we can upload a thumbnail to that. Just to confuse even more, I'm going to use a banana. Now we created a new product, and actually in the back, what happened is that we created an embedding of that banana and made that available in that embedding space that Flaviu was talking about. For that banana, when it comes to the synthetic images, what we're gonna do next is actually upload a 3D asset or an asset of a banana so that it goes through this process of, well, actually it's Unity and we're creating a 3D scene, taking different images of that banana and then supporting our algorithms to actually make a bigger embedding space to find all of the bananas all over the world, more or less. It's going to take a while, but maybe it's definitely something to do with the connection. I'm not sure if I'm going to show you the cool 3D view we built, but it's not that fancy, to be honest. And not really that important, especially for you guys. We already have like 5 products for you to test out. So it's, so if you're going to reuse this banana thing. Slow internet connections and huge 3D asset files don't really work well together. But let's see if we can upload that. The thing is, we have like some reference object in the 3D viewer, and it's also a car. That car is quite big, because the thing is, when you work with 3D assets, it's an issue with, there's a size issue. So if you used to work with CAD tools, like AutoCAD or whatever that's called, you can be very precise in millimeters and whatever. But with our 3D viewer and having a bunch of different 3D extensions with models, we can really make sure that you upload a banana and that banana is like, I don't know, 5 centimeters. And actually banana first scale is a thing, I think. So while this is still uploading, just gonna open up a new tab. So the other thing, we finished up onboarding new products. That's one thing. The other thing we have is we want to create a detection job, and we want to just label products on an image. Imagine that you're a supermarket, you have a camera on top. This camera films a shelf, and you just want to see like how many products are in there, for example. So we don't want to label those products, we just want to see a bunch of different products. And this is what you can also try it for yourself. You don't see all of those product detectors. That's okay, because we don't want you to choose from all of them. And we skip the labeler. We're going to skip the planogram creation. If you want to know more about that, I'm more than happy to talk with every one of you after this workshop. And now we created this new detection job. It's quite easy. And this is a developer experience. So you have like this somewhat nice whatever interface, but actually you can copy this URL, but more to that later, and you can inspect images. And normally you would send an image with a post request or a curl request. We see this part automatically, and this is what we want to see you guys test out the platform. And once we upload a new image, where is it? There. From a store, I think it's include. Yeah. And yeah, upload times, maybe the 3D asset is finished. Yeah, that one finished. And we don't have a progress bar for that because we don't think that people are gonna actually upload images with the web platform, but it should come via API and automatically. Maybe I'm gonna use the hotspot sooner or later. You have one ready? Nice. Is it already there? Which one? This one. Yeah. That's very secure. I know. All right, let's retry. Because that doesn't work, so the password is 1 till 8. I guess the rest of you already know it, but it's important. You need to have a fast connection at least to upload some images. And here we are. So once you upload an image, that goes through some sort of pipeline. Yoshimitsu kicks in, and it detects a lot of objects. So this is what you actually can do yourself right now. The other thing that you can do is you actually want to label products, and this is the interesting part because we have those embedding spaces, and we want to know like which products are actually on the shelf, for example. Let's call this job label, and we're gonna do the same thing. And we want to see those 4 products. Smantana, whatever. I don't even know what it is. But I heard it's good stuff. All right, and we're going to re-upload the same image just to show you that I'm not lying to you. Hopefully that works. Here we are. And now we label those products. I mean, it's a very long product name, but we have this overview where you can actually zoom in and see how we draw the boxes, whatever. And the thing is, now we actually, let's say you're working in the store and you have new products you want to onboard, and we just uploaded a new product. And to make this super fast, we just gonna, first of all, we have this Smantana, whatever it is, and we're gonna upload a new image for this product. because we want to label that and imagine that we uploaded a bunch of embeddings beforehand, but the workflow in the future will be you update that asset or upload a new 3D asset, then you go to the same job, you edit it, you choose the one product that is now in that shelf, for example, and we're gonna upload the same image once again. And this is like, it's that area on the left bottom where we actually, our detector detects, but it's a wrong product. And now, as you can see, it detects the proper product. Although, I mean, it detects a lot of other different things as well. But this is still the beginnings, and we made a very optimized version for today. And we would like to try it out. I hope you guys can all log in, and we would like to help you walk around. If you have any questions, we would be very interested in the solutions you come up with. And we have several products for you to try out. And yeah, there's one last thing that you can try out today. Let's call it single images for a single product. So you got to choose the single detection labeler. And we're going to go with the Spontana again. Yeah. All 5? Oh yeah, because it's intelligent enough. I know. Single. And we upload a single one. For example, that. I mean, it's the same image as the thumbnail we uploaded. But this is actually, I mean, this is machine learning, and our detector detects that this is actually the product that we uploaded. So that's good. This is what you're selling to customers. Now give us money, please. All right. Maybe do you have something to add, or? No, I think we're good to demo. Okay, then please go ahead, try your stuff. We'd like to help you walk around. We have our colleagues with us, and they're more than willing to help you and guide you along with the product. And I think we have till 5, or like 20 minutes. So 20 minutes, try stuff out. If you have other questions regarding our solution, the technologies we use, whatever, we're more than happy to talk to you on your.
So we're going to have the images, a few test images. You can scrap the web for some others, for supermarkets, and go for generic detector. Or we have some live products here, which you can take pictures of. Mostly. And you can try the single detector out. That's it. So this is the link to download some test images if you want to download them.
Or of course you can take your own images with your phone and upload it from your phone. I mean, the website isn't optimized for phones, so. Good as new.
I think this one's the one that's broken.
All right.
You should have done that for the demo. Take a picture and show us all. Instead of uploading the same picture.
It's a workshop, so we thought like, oh, developers want to get their hands dirty and want to break our system, so please break it.
I guess for the people online as well, this link works with the images. Go ahead and give it a try. I can go and ask her to give them some credentials. the sheet?
For the online peeps, you can use the credentials I'm sharing right now, maybe, and break the system, or be surprised how stable and performant it is. While I'm uploading some stuff, I don't know, if anyone has some questions or whatever, for like in general, like feel free to ask them right away, or just call me over.
How do you actually transform the pictures in 3D models?
That's definitely more Flaviu's domain than I am, but
Hello. We use photogrammetry as one technique to take a couple of images and then you combine them. You stitch them together, you create a mesh. The mesh, then you apply a texture on it from the image. There's a cleanup process and you have a 3D model.
Hello, Internet. Yeah, you made the argument at the beginning that creating simulated data is cheaper than collecting real data. Have you collected real data? Do you have any sense of like how much more expensive it is, or how do the two relate, I guess?
I can take it. So, being on the side that dealt with annotators and had to explain how to label them, go through human errors, and look at the bill at the end. Synthetic data is, we're talking about cents and like compute time for thousands of images. And I think we're talking about 8 cents per bounding box, average market price.
Cool. Yeah, sure. Compute time is cheap. We know that. But the techniques you talked about there, they take time, right? There's a manual element to that. So I was more interested in like comparison, like how long does it take to take a video or 1,000 images of a Coke can versus building a 3D model through photogrammetry and then rendering it through your system?
So the cost on building the 3D assets is pretty, it's just 6 images, right? That you can collate to photogrammetry and create the 3D asset, and then you build a synthetic pipeline that builds the variations. That takes a lot of time. That's true, like building a synthetic pipeline that is able to do that. But acquiring the 3D assets is, I would say, considerably cheaper. Yeah.
$15.
Thank you.
But fundamentally, the difference is that you don't have control over the data. Whereas in this situation, you have control over the data you acquire.
I think maybe Maybe it's because you're close to the speaker.
So if you do the demo, you take a photo and you have different light conditions. That's okay. You have different light conditions. The idea is with synthetic data, you can simulate those conditions. Whereas with real data, if you don't have images of that product with that light, you cannot solve the problem easily, right? So there's a cost associated to keeping up the data, always maintaining the models and always getting more data, annotating, and another thing that we want to mention is that the platform looks like this because going from single detection of objects like you see here to the ones on the shelf, it's a different use case if you think about it, right? In one you have loads of images, different resolution, different size for the objects, and the other one you have a photo that's like 4K. So it's different approach. Yeah.
I guess that you can add this to your pitch that surely lots of supermarkets are already doing a very similar process for their e-commerce store anyway, taking a load of pictures for online, so maybe they just use photogrammetry instead. So maybe the marginal cost is not that much. I don't know.
Yeah, exactly. So if you're, if we digitize assets already and we want to recognize them in a supermarket, going to e-commerce is very easy for us. Whereas for a traditional way of doing it, you would need to relabel, reannotate different data for that use case. Just a simple example is the resolution, right, or the size of the object. If you don't have that size, you can't do it. And yeah, there's augmentation techniques, but they don't quite work if you don't if you don't have the right resolution. Sorry, I'll repeat the question, but can you repeat the?
Image or object recognition. I'm meaning some OCR or maybe recognizing the barcode on the product.
Yeah, we're working on that. So we have the object recognition, the classification part, and then we're working on the OCR and price detection.
So the platform will be only for the manufactured product, nothing you carve it banana, and there are the shape and colors. How you deal with that?
So that was a simple example, but we deal with SKUs, so we deal with stock keeping units that have a barcode and a product code, let's say the EIN code that you saw there in the update product. We deal with products that have that. So
okay, and this technique of not collecting real images will be applicable in the outdoor because there are a lot of change outdoors.
yeah, that's the idea that we can. So the question was, is the technique applicable outdoors?
Yes.
And the answer to that is yes. You still need to see some real images, but the idea is you can adapt very quickly with synthetic data to another domain: outdoors, indoors, e-commerce.
Outdoor, the images are not clear. Maybe it's something in the ground or something like this that detected. It's possible or not quite?
Yeah, so if you have occlusions for the object, maybe you have outdoors occlusions, you can generate synthetic data with occlusions.
Okay, thank you.
Yeah.
I'll ask another one if nobody else has got one. So there's a lot of people working on very similar systems, kind of generic systems in terms of cloud services and open source software libraries. There's also lots of proprietary companies like Amazon who are very well funded. So just briefly, what's some of your unique advantages against some of those guys? Either the generic ones or the retail specific.
Okay, so yeah, the differentiator. So recently, there's a lot of synthetic data companies that do data, and they sell data. What we do differently is we sell the models. In order to do that, we need to have this loop of improving the models as we see real data and improve the synthetic data and so on. So we're selling the models trained on that data. That's I guess, the key differentiator. Yeah. So we're trying to solve a business problem at the end of the day, not a data problem. Yeah.
I would say the biggest difference from us to the others would be, or our use case is specific to ever-changing products. If it's always going to be the same product, like, I don't know, you're in a factory and you're just checking, I don't know, if the lid is correct, then like our technology doesn't make a lot of sense. But we can adapt within like minutes for ever-changing products. Also, with the 3D artists we have and what they showed us with, even if it's a pack of crisps or chips or whatever, or nachos, when it's deformed, even if it's bread and the bread is deformed, or a can, and we are incorporating all of those things. And in the future, we don't know if this is something that we will manage in the background for our customers, or if the platform will be big enough so that those people can just, I don't know, have like millions of possibilities to configure their specific detector. We don't know yet. It's the same thing with the products. We do have customers who are interested in this on-shelf solution. Might be the future. Might also be that someone else says this technology is fantastic. I'd like to use it in this or that domain. But the thing is that, I don't know. Hopefully they approach us, but we all know it's going to be a little bit different, and we're going to look for the people. But we are all proficient in the company that what we've built is definitely working, and it's there to stay. And we'll see what happens next, I'd say. I can upload a water and see how's that going to get labeled though. Yes. Actually, I don't know how they're called, or am I allowed to say even? I don't know. Yeah, but like, how's the company called? Which one? Yeah. Oshan. Okay, Oshan is one of the customers we have. I'm the engineer, man. I was like, So tell me about the challenges database-wise. Like,
The supermarket wants to detect from those images, and suppliers want to understand that the contract they agreed upon with the supermarket, indeed, they have upon in the so you have 20 products on the upper shelf. Why is it not 30? So someone needs to detect those 20, and usually people go in store, take photos of the shelf, and someone needs to analyze those images. There's a lot of images to be analyzed. Do we have an innovative approach for the CNNs? Not not necessarily. We don't like do research in CNNs, but it's not an easy problem. So we have to try a lot of things. Yeah.
Hi. So in terms of e-commerce, one simple question is, do you think this technology can replace the, let's say, step number X when we need to do a lot of product images, so we need to have a model, for instance, with some clothing brand or even with your food or whatever the product is. You always need to have a professional photographer and an entire team or even teams working on providing the product as it's the nicest way for the customer. So the question is, can this 3D replace that for e-commerce shops? Because this will be also a lot of cost cuts, I would say. So do you see it possible as a replacement for all this pre-setup?
Short answer, yes. So you mean the 3D visualization component of the... Yeah, I think it's a possibility that, you know, we get a lot of digital assets, 3D assets on the platform, and we can give them to marketers or whoever wants those models. But there are other companies that do that specifically. They provide very nice looking 3D assets, and they place them in different environments. So, you know, you want to have a marketing promotion, a marketing like outreach that puts bottles like those ones in on a beach or whatever, right? So you can do that. There's other platforms that do that. We detect those products. So.
You can go way farther than that. When you've, like, maybe you've seen the tech demo of Unreal Engine 5 or whatever, and this is like near, I mean, it depends, but it's like it's getting more and more realistic. So more and more realistic the technology becomes, the better our technology will be. Because in the end, what we do is not much more than what you get in Google Photos, for example. So the more realistic the images are, the more realistic it is that we can use those generated images to detect real objects in the real world. So it's just a question of how fast the technology in those other areas advances as well. We're out of time, I think, or is it? I think we exceeded the 1 hour.
Yeah, I don't know.
Okay. Okay, with that, I think this is 1 hour. It's like, I don't know, 40 minutes? Oh, that's all right.
If anyone has any other questions or opinions on the demo, how it went, I've seen a lot of detections in the room, so that's really good. Great stuff.
Nice. And we now have all your personal data as well because you're in the same room with us. No, thank you very much. We only have this last slide, so check us out at neurolabs.ai. This is the nice looking website. app.neurolabs.ai won't work with the credentials you have. We're going to delete them sooner or later. Oh, there's one important thing. Of course, we're hiring, like every other tech company does, especially in the engineering department. We're looking for someone who has skills in this whole Docker, ops, whatever thing.